So in working with arithmetic sequences and sums, these are going to be the two formulas that you need to know and need to use. They'll be given, so it's not like these need to be memorized, but as we work through a couple of example problems, I will refer to each of these. The type of arithmetic sum problem that you'll see, it'll usually be one of two forms. It might be something like this, where it's just find the sum. And you have this list of numbers, say 17 plus 23 plus 29 plus 35 plus ... And it goes up to some given last number. And so the thought process here, first I'm recognizing the pattern. The pattern from term to term is plus 6, plus 6, plus 6. So constant difference between terms implies arithmetic. And so the formula that I'm going to use is going to be this formula. The sum will equal the first term plus the last term times the number of terms over 2. And so when the information is given this way, 17 is the first term, 299 is the last term, but at this point, we don't know how many terms there are, and so that's where I'll have to use the formula for the sequence here. And so I'll say, for this sequence, a sub n is 17 the first term, plus 6, that constant difference, times n minus 1. I'm looking for n, and so what I'll do here is I'll say, that's the nth term, I don't know what n is, so 299 equals 17 plus 6 times n minus 1, and so now this is the equation that I have to solve. Subtract 17 from both sides, maybe distribute the 6, 288 equals 6n, divide by 6, divide by 6, n equals 48, and so then that's what's going to go here in the formula for the sum. I use my calculator and figure out that that equals 7,584. The other type of problem that you might see, I think this is probably how we started, I would say something like, find the sum of the first 100 terms, for example, in the sequence. And then you'd be given some sequence, let's say 12, 16, 20, 24, 28, ... And so I'm still going to use, well, the first piece of recognition is that for this sequence, the pattern is 12 to 16 is plus 4, 16 to 20 is plus 4, plus 4. So again, constant difference. So arithmetic. I'm then going to recognize that I'm using this same sum formula. And so the sum will be the first term plus the last term times the number of terms over 2. I know what the first term is, it's 12. I don't know what the 100th term is, so we're going to have to find that. But I do know I'm looking for the sum of the first 100 terms, so I can put 100 there. And then to find the 100th term, I'm going to use the formula for the definition of an arithmetic sequence. So a sub n here, the first term is 12. 4 is that constant difference. Since I want to find the 100th term, I'm plugging in n equals 100. And so then I'm using my calculator, figuring out that a sub 100 equals 4 times 99 plus 12, 408. And so to answer the sum question, 12 plus 408 times 100 over 2, use my calculator, and I get 21,000.